Let's do some trig with linear velocity and angular velocity and that stuff. So let's see, we have a word problem today. A moving vehicle's wheels have a diameter of 32 inches. If the vehicle is moving at a constant rate of 30 miles per hour, find the angular velocity of the wheels. So let's go ahead and do this problem. We're going to go ahead and tackle this. So first, let's go ahead and draw a picture. So I'll be right back because I'm going to draw a picture and then I'll show you how it looks like. Okay, so this is my picture right here. This is what a representation of what the wheel might look like. It has a 32-inch diameter, right? 32-inch diameter. And 32 divided by 2 is going to give us 16, which is going to be our radius, 16 inches. So that is a visual representation. You don't have to draw a picture, but I suggest you do just to help you visualize how it's going to look like. So let's go ahead and continue with the problem. So what's already given to us? Let's see. So we have a constant rate of 30 miles per hour. So that is going to be your linear velocity or linear speed, linear velocity. So V is equal to S over T. This is going to be your linear velocity formula you might see in your trig textbook or your trig class or whatever. So this is the one we're going to use today. So V, S is distance, right? Distance. And T is time. So S is distance and T is time. So if we see this problem right now, we are given the linear velocity. And what is our linear velocity? Our linear velocity is 30 miles per hour. So distance is 30 miles. 30 miles. Over time, our time is hours. 1 hour. Let's put a 1 right here. 1 hour. You don't have to, but let's just put a 1 right here just to make it a little bit clearer. Yeah, it's going out of focus. So 30 miles per hour. I don't know if you hear my cats, they're fighting right now, but 30 miles per hour. That's our linear speed. Linear, let's just call it linear velocity. Velocity. Your textbook might call it linear speed, but I'm going to call it linear velocity. Different textbooks can say different things. So let's go ahead and continue. So in order to do this, we need to find a relationship between basically the linear velocity and our angular velocity. We want to find the angular velocity, so we want to find our angular velocity. And what is our angular velocity? Omega is equal to theta over t, time. Theta is going to be in radians. That's important. Theta is in radians. So keep that in mind. Theta is in radians. It's not going to be degrees or whatever. It's going to be radians. So we need to find omega. That's omega, Greek letter omega. I know it looks like a W, but we're going to find omega equals theta over time. So we need to find a relationship that relates omega with V. What is that relationship? We are going to use the arc length formula. So arc, I don't know how to spell length, but arc length formula. And our arc length formula is given to us as S equals R over theta, where S is our distance. This is obviously our angles in radians. And R, you might already know what this is your radius. Radius, right? So that's what's going to relate to finding the angular velocity. So let's go ahead and do this right now. We are already given our distance. We are given the radius. Let's go ahead and find theta. We're going to plug theta into this formula. We already have time. And we're going to find what we need to find. So let's go ahead and plug all of that together. But before that, notice that our radius is given in inches, right? And our distance is given in miles. Let's go ahead and convert our inches to miles. Let's go ahead and do that. So we have 16 inches. That's our radius, by the way. and we're going to use dimensional analysis. If you've taken a chemistry course, this might seem familiar to you. If you haven't, then that's okay. It's best you pay close attention. It's not that hard. So we have 16 inches. And what can we relate to miles? In this case, we're going to use feet. So 1 foot is 12 inches, right? Notice the inches need to be at the bottom, because 16 inches is at the top and 12 inches is at the bottom. Why do they have to be at the bottom? So these units cancel out. So we're left with feet. When we do the multiplication, we're going to be left with feet. Multiplication and division, we're going to be left with feet. So let's go ahead and relate feet to miles. So 1 mile, again, feet need to go at the bottom. So these units can cancel out. Feet can cancel out. So what relates to 1 mile? It's good to know this. There's 5,280 feet in 1 mile, right? Again, these units will cancel out because this one's at the top and this one's at the bottom. So if you see here, we're only left with miles as our unit. So that's what we want. So let's go ahead and do the whole multiplication right across. And you should get, let's round to 2 decimal places, because if you're in chemistry, you'll see that you'll round to like 2 sig figs or whatever. So let's go ahead and round to 2 decimal places. So we're going to get 2.6 times 10 to the negative 4 miles. Or miles. So that's what we have. That's going to be our radius, and this is radius. So that is what we have. This is scientific notation, by the way. If you don't want it in scientific notation, you can write it as 0.00026, because that's a negative 4. 1, 2, 3, 4. Yeah. So that if you don't want it like this in scientific notation, then that's okay. You can write it like this, but I prefer in scientific notation. So let's go ahead and continue. Let's see what else. Now we can go ahead and apply our arc length formula of distance equals radius multiplied by theta multiplied by our angle. So our distance is already given to us, right? Our distance is 30 miles. Is equal to our radius. What is our radius? Our radius is 2.6 times 10 to the negative 4 miles. And our theta, that is what we're going to look for. So now this is easy. We just have to find theta. And the way to do that is just divide all of this, by 2.6 times 10 to the negative 4 miles. These will cancel out. This one will divide with this one. And your theta should be around, let's see, theta is equal or roughly equal to, this is a rough approximation, because you're going to get a decimal, but we're just going to roughly approximate to. Your theta is going to be equal to 117,188 radians, because remember, theta is in radians. Now we can go ahead and find our angular velocity, with omega is equal to theta divided by time. In this case, we already know our theta, which is 117,188 radians per, what's our time? Our time is 1 hour. And that is our answer. So that is how we do this one with finding our angular velocity. So that is it. Super easy. Just work on some dimensional analysis, some relationships between these two, maybe your scientific notation, and that's it. Super easy.